Okay, remember I put all of these on the Moodle, so feel free to go on the Moodle domain, Stats 13, and then you can view them all there as well for review. Okay, in a sample of 8, when you see a small sample, that's a T-score, not a Z-score. Z-score is your major one, greater than or equal to 30. It also, if you remember your flow chart, and I put it in the little flow chart in your review packet, it also checks to see if you know your population standard deviation. If you know anything about the population, then you can use the Z, but if not, we use a T. So we find your mean. Here's your sample. They're still talking about your sample. Here's your mean, and here's your sample standard deviation. Pull your information out. Write it out. Because otherwise, when you go back, you're looking at numbers, and you're going to grab any numbers that you see. So make a little box, and then put your level of confidence out here. Okay, so you want to assume that they're normally distributed. We need to know that because this is a small sample. And we're going to use a T to find your confidence interval. Again, your confidence interval finds your mean plus or minus your margin of error. Now, basically, we're already given your mean. We just need to find your margin of error. So we use this formula, and your critical value, your TC, says go to table 5, follow across to the top, level of confidence 99%, degrees of freedom. So if your N is 8, your degrees of freedom is 7. I like the chart because it kind of leads you right into seeing what you need to look up. If you look across, it says level of confidence on your chart 5. Down the left-hand side, it says degrees of freedom. That's your critical value. There is only one, and it's constant. So we bring it out to your critical value. Morning, Mark. Then fill the rest in. Standard deviation divided by the square root again. Okay? That's your margin of error. All you have to do is put this right into here. Just build it. Okay? The Z-score works the same exact way. The Z-score, the only thing is you have to do the 1 minus divided by 2 on your inverse norm. This I think is even easier on a T. You just have to recognize that it's a T. You have to know that it's a small sample and there's no population standard deviation. Make sense? Yes.
When we find the answer, will this be like a part 2 question, like not multiple choice?
Probably this one's more like a part 1 because I really didn't have you figure out your mean or give you any like data. I just gave you the mean. Really, all you had to do was figure your margin of error.
But if this was like the first one, do we need to show like plus or minus, like add the 7, 8?
Well, yeah. All I need you to do is just like give me this statement and give me the interval. I don't need to see you adding it or subtracting it. Just like show me that you did it. If you use your calculator for this one, you can even use your calculator T interval. If you use your calculator, which is fine, it'll just give you the thing back. If you want to give me your margin of error, just subtract your mean from the highest one. And that's your margin of error. Just go like that if you use your calculator. Okay? If you guys, T interval works great on your calc. Just give me your interval. Tell me you did your T interval. And show me your margin of error. Subtract the mean from the highest interval, and then just give me that part. Make sure I do see the T interval, because if your answer is wrong, and you use the Z interval, but I don't see it, there's no way I can give you credit at all. If you showed me that you did the Z interval, then I could say, we used the Z instead of the T. Maybe that's just a couple of points out of all the points. At least it's not all the points. The rest of it works the same. But if I don't see it, I can't give you credit. Plus, if it says you have to show work, and remember, guys, I don't grade your tests. I'm not grading any of your tests, someone else's. Mr. King from North, and Ms. Fernandez from here. grade your test, not me. It's my SLO. I don't know if you hear the teachers talking about that. So I'm not allowed to grade your tests. So you need to remember to show as much work as possible. I did all the work out, and Ms. Fernandez and I have always worked closely together, so she helps Mr. Keene grade for me. She takes my place. And I do her pre-calc honors. Okay. But that's why I need to see work. I lay out all the work and how many points come off if you use a Z. Say it's work 5, I'll take 2 points off if you use a Z. She knows exactly, but if you don't show it to her, that's not there. All right, in a survey of 1,037 adults, there's your N. 643, there's your X. So we find a proportion, a point estimate for your proportion. You don't know anything about your population, so you use your sample. So your sample says, find a point estimate, X over N is your p-hat. So make sure you build your proportion, or when you use it in your calculator, if you use your 1 proportion Z interval, you need the X and the N if you use the calculator step. This is your p-hat, your q-hat is 1 minus that. Construct the confidence interval. Now don't forget, your formula sheets are separated by proportion, z-score, t-score. So you should be able to go in there and to look to see which set of formulas to use. So build your proportion, 1 plus or minus your margin of error. If you notice, that's key to each one of these. Your z-score, to find your ZC, again, 90% falls in here. The rest share 10%. So you're doing 1 minus 0.90 divided by 2 in your inverse norm. That's where your 1.645 comes from. Okay, fill in your p-hat, q-hat, divide by n, there's your margin of error. If you use your calculator, 1 proportion, z interval. Find your minimum sample size. We don't do a sample size for T, just a Z. For your regular Z and for your proportion. It's the same formula as your margin of error, we just solve for N. And I gave you the alternate formula, it's on your sheet as well. Remember to round up when you do this. Find your answer and round up. Okay? Make sure you have this down. This is all you need to study. Make sure you have it. These are like good examples of each type of problem that you'll possibly see.
You said minimum sample size was the T, not the Z.
We use one for a Z and we use one for a T. Oh, sorry. We use one for a Z, we use one for a P. We don't use a sample size for a T. Because your T is your small sample. So we don't have a formula for sample size for T in this course. We're very basic statistics. But a z-score, anything with your z-score will have a sample size. Okay, referring to the data in 19. 19 was this guy, your washing machines. So here was your sample mean, your sample standard deviation for 19. And now we want to build a confidence interval for the variance. So we had your mean and your standard deviation. The mean was, we didn't care about the mean actually. We don't care about it, but we do care about your sample standard deviation. Okay, remember this is the chi-square. This is also table 6. And I give you all the tables that you need to work with. So on table 6, you need to be able to find your critical values. The formula is scary looking, but n was how many was in our sample, and that was 30. We had a sample of 30 from number 19. So n minus 1 is actually your degrees of freedom. So there's your 29. This guy right here, sample standard deviation. If it's a standard deviation, you square it. The both numerators are exactly the same. The denominator is where your critical value comes from. And your critical value comes off your table. So I said, don't be concerned about which one is right, which one is left. The left one and the right one go in numerical order. So your curve goes like this, from 0 to infinity. So when you look this up, and you're in degrees of freedom, and you're in your confidence interval up here, so your point, oh, and you have to do that other formula. 1 plus c over 2, I should make sure you have this formula. 1 minus c over 2, in order to help you get that. So your confidence interval is 95. 1 minus 0.95 over 2 gives you 0.025, and the other part of it is 0.975. So you're going to look up along the top, 0.975, degrees of freedom 29, and you're going to get your value, 16.407. Then look up 0.025, you're going to get this value. When you put this in your formula, this is an inequality. Small, medium, large. Remember it like that. This points to the smaller one, the guy in the middle, the guy in the end. Small, medium, large. So the larger number has to go on this side. Even though this one is the x2r, and this guy is the x2l. The left one has to be switched around. And you'll notice it if you did it backwards, because then your inequality will just be reversed. And just swap them around. Don't leave them reversed. Because this inequality says this is less than this, less than this. Yeah.
This may be a dumb question. I was going to ask you if you can give us all these formulas.
I give you all the formulas. You know the page that I gave you that has it laid out by chapter? It should be in your chapter 6. Look in your chapter 6 as a matter of fact and see if these formulas are there. The 1 plus c, 1 minus c over 2. I can make sure that that's there. Was that on my set of formulas too? Is that in chapter 6? How about on my sheet? You have my formula page?
Yeah, this right here.
Is that mine?
Oh, there.
Okay, good. I'm giving you both. I'm giving you both sets of formula pages, whichever one you're more comfortable with. Some of you like the one from the book. I find it's got too much information sometimes.
And here's another question. We're going to have a test in order, like chapter 1 to 3.
No.
Let's
No.
make sure all mixed in.
Tests are all mixed up together. Your review is in order, which helps you review for it. Once you get your variance, guys, to get your standard deviation, you just square root everybody. You need to get the square root of this to be this. So square root everybody. The big one and this one are your critical values. Table 6. Degrees of freedom, and don't forget to do this piece right in here. This piece is important. Good? One more, that's it. Okay, hypothesis test. Hypothesis test should be easy because that's the one we did last. So what I thought I would do is when I give you part 1, I'm giving you part 3 at the same time. That's your hypothesis test. You only have to choose 1 out of 3. So one's going to be a Z, one's going to be a T, one's going to be a P. And you can pick which one you like. You may even want to go by who's greater than or equal to, who's less than or equal to, who's equal to, whichever way you're more comfortable with. But I lay this whole part out in front, A, B, C, D, E. I need all of these pieces answered. And my advice is label them. Again, I'm not grading this. So for whoever's grading this, make sure they see what your pieces are. If it says state your decision, Your decision is reject HO, fail to reject HO. Your interpretation is your chart. If it was the HA and I failed to reject HO, then I say there's not enough evidence to support the claim that, and you put the claim in there. Make sure all that is in there. So let's take a look at this one. A citrus grower believes that the mean, I got the U, of the mean utilization of fresh citrus fruits by the people in the U.S. is at least, there it is right there, at least 94 pounds per year. Think money in your pocket. If you have at least $94, do you have more? Yep. So your mean is greater than or equal to 94. This is your claim. If it has an equal sign, this is the HO. The HA is the complement in this case that does not have the equal sign. And your tail follows your HA. Whatever the HA is, that's where your tail is. So you sketch. Your sketch has to have the tail shaded on the left-hand side. This says reject H0. This says fail to reject H0. Okay. Find your critical value. Let's see what we asked. Did I say that you had to use your p-value? If I don't say which one you need, you can do your p-value, you can do your critical value. I forget what the test says exactly. So find your n, do your pieces, do your z-score. Remember your z-score has a sample in here. You have a random sample, pull this out, of 103. You have a sample mean of 93.5 and a sample standard deviation of 30. Here's your level of significance. Can you reject? The word reject is only used for HO. So check your claim is your HO. It's a good check before you go on. So set it up, find what it is. I think in this case, I did your p-val test. No, I did your cutoff. I did your critical value. How do I find that critical value? Anybody remember? Inverse norm. So you want this tail to be 2, a level of significance of 2. This is the smallest error that will allow. This is like the opposite of your confidence interval. So inverse norm 0.02. And again, if you do inverse norm 0.02 and it's on the left-hand side, it is negative. If you do inverse norm 0.02 and the tail is on the right-hand side, make sure you put it as positive, even though it's still going to stay negative. Don't do the 1 minus it. Just do the regular 0.02 and place it. If it's to the right, it's positive. To the left, it's negative. Okay? Find your test statistic and see where this falls. This is going to fall closer to the 0, so therefore it falls in the fail to reject. If you test your p-val, follow this chart up there. Put your p-val here. Your p-val is, here it is. It's whatever this z-score is, go to your chart, look up your area to the left. There's your p-val and your level of significance. Fill it in. And less than or equal to. So you failed to reject H0. Make sure you give me this statement as an interpretation. This right here is your decision. It's really, really important, guys, to lay all these pieces out. And make sure you label them. Because I'm not grading this, someone else is. So they're not used to searching around, remember.
Do we need to know p-val?
I don't think I specifically said p-val. Does the directions above say if p-val or rejection area?
Yeah.
Yeah.
If possible, find p-value.
Okay.
What does that mean?
You would have to use your calculator on the T. On the T-score one, you have to use your calculator to find p-val. But on the Z-score, you can use your table. As long as you give me a test somewhere and I see where it's going, it should be fine. Can everybody find the claim, the complement? Which one's the HO, which one's the HA? Make your sketch. You only have to do 1 out of 3 of these. So if you don't like an at least or an at most, maybe do an equal. If you do an equal, be careful. That's when you have to divide the level of significance by 2. You have to share it in 2 tests. Okay? Alright. Same setup. An automaker estimates that the mean, oh, we got another mean, U, of its luxury sedan. Oops, I gave you another at least. Mu. It's pronounced mu.
Oh, I thought you said yo.
No, mu. It's pronounced mu. It's with our mu. We use a U. It's pronounced mu. A random sample, sample of 8 means we have a small sample, means we have a t-score. Okay? This was your sample information and your standard deviation. Now, when you do your hypothesis test, we won't, in our course, have any population standard deviations because we're making an inference about our population through our hypothesis test. So you're only going to get information about your mean in here and your sample. Again, set up your claim, HO, your tail, HA. Find it. This one's easier to spot. Where's my tables? If you go to your table 5 is nice. It has a 1 tail or a 2 tail. So we follow your 1 tail. You find your 0.05 level of significance. Do your degrees of freedom 7, and you come out with your 1.895. Can you all follow this? Mm-hmm.
That's P-val?
See, that's the cutoff value. That's this. The only way for you to find your p-val is to put this one in your calculator. We can't get an exact area because this doesn't give us any areas on this. So the only way for you to find the area related to this t-square, remember your t-curves slightly change, they change all the time. They stay normal, but they change. So the only way for you to do this is with your t-test. If you use a t-test, it gives you a p-val. And it just says p equals. So if you use your calculator, you can find your p-val. If you don't, then you can't. Use your critical cutoff. Can everybody find a cutoff? You find your cutoff, yes? Okay, find your cutoff and test it. Falls in the fail to reject H0. This is your decision. Make sure you state it. I can see it. This is your interpretation. Make sure I see it. Is this the one I said you didn't have to do? No. The next one. Okay. All right. A maker of microwave ovens advertises that no more than 10%. Percent? What does percent begin with? P. Oh, we got a P. Percent proportion. We flip this one to a decimal. Don't forget. No more than. If you have no more than $10 in your pocket, so you have 11? No. So you have less than or equal to 0.10. This is your claim. HO or HA? HO. So the HA is the right tail test now. God bless you. In a random sample, here's your information. You have 57 microwaves. You have a p hat of 0.13 at a level of significance of 0.04. Okay, 0.04, that helps us find this. Inverse norm, 0.04. When you put this in, it will say negative 1.75. But because it's a right tail test, it's a positive 1.75. That's the only difference. Rather than have to subtract it from 1, just do the negative and remember to flip it to the positive. This is your critical value. That's where your cutoff is. This is your shaded reject H0. This is your fail to reject H0. And make sure you say H0 with that. 2 ways. You can use your formulas, and I give you your formula for this, for your Z-score. You need to know your P and your Q. We don't use Q hat, P hat down here. We use your P and your Q. So you've got your P hat minus, this is like your sample mean minus your mean. You have your sample proportion minus your population proportion, divided by your P hat, Q hat, all over the N underneath the square root. Remember, if you do this in your calc, to put parentheses, because it won't work if you don't. Well, it'll give you something different, but it won't be right. Here's your decision based on wherever this falls, and here's your interpretation. Yeah, I didn't have one that had reject, huh? Good? I think the hypothesis would probably be a good place for you to start. If you go back to problem, the last one in chapter 5 was line 18, which is probably number 3.
And 4.
And 4? 4? Okay.
Yeah.
This one was a discrete situation, a binomial. They say yes, they say no. Remember, your binomials have bars, and there's a gap between a 12 and a 13 because there's no decimal or fraction because it's discrete. So you have to do a correction for continuity in here. I think we kind of just like breezed through this yesterday. I don't think I pointed this out. Remember your correction for continuity. If it says your probability that x is less than or equal to 15, we could have 15, 14, 13, blah, blah, blah. Remember how we did this? If it was the high end, we added 0.5. And we put that in your statement. And we use that over here. Slightly different answer. If it said x is greater than 15, what number would I start with if x is greater than 16? Well, no, what would be the first valid number I could use? 16, right? 17, 18, blah, 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 blah. Drop this guy down to 15.5. You will never hit a 15.5 because it's a discrete value, but you have to correct this for continuity. If I said x is less than 15, what's the first number that's valid to use? If I said x is 14, so this is how you correct. 13, dot, 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 dot. Take the high end, make it 14.5. That's your correction for continuity. So I kind of forgot to put that in there yesterday. It was in here, but I didn't mention it. So I wanted just to go over and mention it. Okay.